What is up, my legions of Fiverr 9 YouTube followers? This is the part where we actually start troubleshooting. And troubleshoot we must, because now that the amp is all put back together and we got our new capacitor in there and we got some nice, really good old stock 6L6 in there. The amp works, it amplifies, but it is drawing way too much plate current, in the order of about 34 watts per tube. So that, I can't even really show you that, because I won't let this thing be plugged in for more than a minute doing that, because it'll just destroy the tubes in very short order otherwise. So troubleshooting, we got to figure out why, when everything is rebuilt, does it run so much hotter than it should? And the answer has several components. First of all, as I've said in other videos, the line voltage is higher these days than it was in the 50s when this was put together. 120 was a pretty high for those days. It was more commonly 110 or maybe 115 on the high side. So on average, our line voltage today is 5 to 10 volts hotter than it was back then. So that's one reason. The other reason is that the original diodes in this circuit probably had a higher voltage drop than the ones in there. So that might account for a few volts, but probably not much more than that. There is a possibility that these are particularly hot tubes that they, want to draw a lot of current, but it really probably boils down to the line voltage mostly. When we take a look at this point here between the diodes and this first 150 ohm 10 watt resistor and the first capacitor stage, it's expecting a measurement of 440 volts. I'm getting about 480, 485 at this junction right here. So we know that our B plus is hot coming off right off the bat. The 150 ohm resistor measures about 155 ohms, so it's actually, helping us more than hurting us by being out of tolerance. Well, not that it's out of tolerance, but being higher than its stated value, it's helping us. And the same thing over here with the 250 ohm cathode bias resistor. It's coming in at about 260 something ohms, so it's actually helping us by being slightly higher than its rated value, or than its schematic value too. So we have to get this under control, and there's two ways to do this. We can either try and knock the voltage down more by messing with this, and that probably means dissipating a lot of heat to do that, and changing the power supply fairly drastically, or we can try and increase the value of this cathode bias resistor, and that is what I'm about to do. So I'm going to put this on pause for a minute, and what I'm going to do is I'm going to take one of these 5 watt 75 ohm power resistors, and I'm going to insert it in series with the 250 ohm resistor, giving us 325 ohms. It'll probably be closer to 340 ohms, because like I said, this 250 ohm is measuring like 260 something. So that should be hopefully about the right ratio to get the output tube dissipation under control here. So let's pause for a minute and see what happens after we tack in a 75 ohm resistor. And by the way, my apologies for all the noise. It's cold out here in the garage. I've got a space heater running, and the furnace will periodically kick in to heat the house. What can I say? Okay, so where there was once a wire bridging the 150 or 250 ohm resistor to the first cathode, which is then jumpered to the second one, there is now a 75 ohm resistor. So we've just added 75 ohms in series with the 250 ohms, and I'm not sure if I can take measurements while holding the phone and watching to make sure that this doesn't blow up. But let's try. So, well, actually, no. First, I got to plug all the tubes back in. One moment. Okay, so now we've got all the tubes plugged back in and the capacitor and everything, and you got the dummy load speaker hooked up there. And let's see here. Try and do this. Okay, so I'm going to go ahead and plug the power. In. And while it warms up, we're going to watch. I'm going to measure from here, and I got that on ground. And we're going to watch our cathode current rise as this thing warms up. Whoop. Come on now. Give me a reading. Okay, good. We have a much higher voltage drop now across this resistor. We've added about 5 volts of voltage drop. I'm not sure if that's enough or not. Let's take a look at measure our B plus voltage again. Voltage DC, B plus. Yeah, still close to 490. And again, about 40.8 volt drop across both of those cathode bias resistors. So let's do some calculations and unplug this thing while we wait. And let's do the calculation. Okay, we're back. So it got us closer, but we're still dissipating at about 105 to 110% of what the tubes are rated for. So 75 ohms, it doesn't look like is going to be enough. So I'm going to try and pull that out and maybe go up to a 100 ohm resistor and see what we get with that. Maybe even 125 ohm if I can find one. All right, be back in a minute. All right, so now we've got a 100 ohm resistor tacked in series there. And with that 100 ohm resistor, our voltage drop across the cathode bias is 42.3. Our plate voltage is at 490. When we subtract the cathode voltage from the plate, we get like 448 or so. Let's see here. Then doing the calculations, that puts our plate dissipation at about 94% of maximum, which is still too high. They're not gonna melt down here on the bench, so I can run it for a minute, and we can see that, yeah, those tubes are definitely running right along. They're not red plating. I can definitely smell the dust heating up on them though. So yeah, we are probably going to want to increase that 100 ohm to 120 just to get the tube dissipation a little more under control. And that will probably do it for that, and we'll be ready to actually start putting sound through it and checking it out. Alright, so I'm going to pause this for a while and do a little more work in here and see what we got. Alright, so where did we wind up? My phone battery died. Not sure if I recorded this part already, but I wound up replacing the other resistors that I had tried sticking in series there with another 250 ohm resistor. So that's two 250 ohm resistors in series, or 500 ohms. It's actually about 510 ohms because that first resistor is about 10 ohms over value. So with this arrangement, we have managed to get the plate current to within acceptable limits here. It's about 78-ish% of the maximum plate current rating. We were shooting for 70% for the safest, longest life of the tubes. But I think with this particular pair of tubes, 78%, I mean, considering we had to double the cathode resistor value. So, why did we have to double the cathode resistor value? Well, again, look at here, 440 volts is what it's supposed to be on this side of the diodes. we're getting over 500. So it's like about 65 volts higher than expected. And yeah, so that has an obvious effect on the plate current if you don't do something about the cathode bias resistor. And if you happen to have tubes that draw more current. Although these tubes aren't particularly, yeah, I wouldn't have expected this with this pair of tubes. Let's just put it that way. So why did that happen? Again, probably has to do with line voltage. I mean, we got 117. Here's what it's expecting. You know, my line voltage is probably closer to 122. So that's, you know, like about 5 volts higher right there. And that's going to translate to some more B plus here. Plus these new filter capacitors, they're probably, you know, they're probably more than 30. Even though they're rated at 30, they're probably stronger. That might have something to do with it. And it just, you know, these voltages were high to begin with. And with modern line voltage, they're even higher. So it is what it is. There's not much you can do when you're getting 500 and some volts out of there without really dramatically increasing, say, this 150 ohm resistor here and bringing the overall B plus voltage down. I might look at that and experiment with it, but I think we're fine for now. So this amp is now runnable, and the tubes won't run away and melt. So we've got them all in there. Over here, I've got some test wires soldered up to a socket that is powering the amp. So we've got our AC input voltage here tacked onto a cord. And over here on this Army signal caller generator, we've got an 8 ohm resistor parallel to the output that is feeding in here. Because remember, this is a booster amplifier. This thing is expecting to pick up an amplified signal from an amplifier that is across an 8 ohm load. So we're making sure that our signal core generator here is set to the closest impedance possible to 8 ohms, which is 10 ohms. And we've got a 8 ohm resistor there. So that's in the ballpark. We don't need it to be precise by any means. So without further ado, and we've got this speaker here hooked up. So we should be able to now plug in the amplifier, and once it warms up, we should get some signal. So let's take a look here. Are those filaments glowing? Yes, they are. This thing heats up pretty quickly. And I don't know if you can hear that because it's a really low frequency, but already we're getting some output. So let's crank this up. All right. So this amplifier is going all the way down to 20 hertz. Hertz, you can tell that's where the speaker's resonant frequency is, because boy, it gets really loud right around 100, and then it, you know, drops off above and below 100. So this might get loud here, so let's turn the output down. Let's put it on the 200 hertz to 2 kilohertz range. It's loud, all right. You can tell that this speaker is clearly a lot more efficient when you get into the 600 hertz and up range. Yeah, above 800, above 1K, it really starts getting louder. So that's kind of to be expected. This is, after all, a guitar speaker. It really shouldn't have been in this Leslie cabinet. We've got a speaker from Weber Speakers coming that it should be a good match for this cabinet. So now that we have the amplifier working and drawing acceptable plate current, we can start thinking about putting things back together. Before we do that, I'm going to check the plate current on this little 12 AU7 and make sure we're not frying him up due to the increased B+, and we'll go from there. But the amp works fine, no crackles. I didn't replace the pot. It's fine. That 12 AU7 is kind of microphonic, isn't it? And all the tubes on this thing are a little bit microphonic. That one's sort of coming through the amplifier. That one's definitely coming through the amplifier. That one's really loud coming through the amp. But it's shock mounted, and we can always try to swap it out with quieter tubes. For now, I'm very happy with it. So that's pretty much it. We can see that this amp can handle its full frequency range. Let's go up into the high. Okay, this could be painful here, guys. Your dogs might not like this. Ooh, up around 11K, 12K, 13, 14, 15. I'm not hearing anything, and it wouldn't surprise me. I'm not sure that my hearing is good above 13, 14, 15K anymore, but also I'm not sure this big old speaker is any good up here too, so yeah. Woo! That was ugly loud. Sorry, everybody. Anyway, we have a working amplifier. Next thing is going to be troubleshooting the motor control unit. I found a blown resistor in there that's making the braking circuit inoperable, and we'll get into that in the next video. And then hopefully get into reassembling everything and testing it out, and then connecting it up to a Hammond organ that's never been connected to a Leslie before. So that'll be fun. All right. Bye-bye.